Hello students, welcome to video lesson 8-4. Today we're continuing our discussion of the double distributive property or the FOIL method, whichever it is that you personally prefer. And we're going to do it in a couple of special examples, things where there maybe are some shortcuts to the FOIL method or double distributive property that you could use but certainly will not be required to use. The first of which is when we have a binomial, like we've been seeing when we multiply together with the double distributive property, but we have it squared. So in this case, n minus 7 squared is our first example, okay? N minus 7 squared, what I want you guys to think about is that n minus 7 squared is not equal to n squared minus 49, okay? So I don't just get to square each of these pieces, okay, because there is that subtraction sign in the middle. So if I were to just do this, n squared minus 49, that would absolutely be incorrect, okay? Do not do that. You do not get to square the two pieces of a binomial if you have that binomial squared, okay? It's all because of this minus or plus sign in the middle here. Same thing over here, because I see a plus sign, I cannot just square each piece separately. And the reason for that is because we're sort of skipping over a part of the FOIL method or the double distributive property that is important. And we can see that if we think about this particular example more like this. Right? So here I have n minus 7 being multiplied again by n minus 7. And that's really what this is saying. N minus 7 squared is like taking n minus 7, multiplying it times itself. So if I'm going to do this, this looks a lot like the double distributive property that we were just looking at in our last couple of videos, right? Specifically, the first one from section 8.3. So if I were to multiply these together with the double distributive property, n multiplied by these two guys, and then the minus 7 multiplied by these two guys, I'm going to get my regular 4 pieces. Okay, I'm not just getting n squared, I'm not just getting 49. I am going to have an n squared as my first piece from n times n. I am going to have minus 7n from n times that negative 7, n times negative 7. And then I'm going to have another one of those. Okay, another one of those, negative 7 times n is another negative 7n. And then at the end, I have negative 7 times another negative 7. Interesting thing here is that it actually becomes positive 49. Okay, it's not minus 49, it's plus 49 because of that negative 7 times negative 7. Okay, so if I put these two middle pieces together like we know we can, n squared minus 14n plus 49. Okay, n squared minus 14n plus 49. So when we square a binomial, make sure that we treat it as n minus 7 times n minus 7 in that way, okay? Same thing over here with 2x plus 9 squared. We need to treat that as if it were saying 2x plus 9 times another 2x plus 9. Okay, and then again, this is a double distributive property where I'm going to do 2x times 2x, which is going to give me 4 times x squared. This is going back to, like I said, our first video from section 8.3. 2x times a positive 9 is going to be plus 18x. Then in the middle here, I have 9 being distributed to the 2x. That's another plus 18x. And then my last two pieces are 9 times 9, and that gives me plus 81. When I combine these things, I get 4x squared plus 36x plus 81. Okay, so it becomes a normal quadratic trinomial, just like we've been seeing previously with our FOIL methods and double distributive property. So it's important to recognize a binomial being squared for what it is. It's a binomial times another binomial, exactly in the same way that we were dealing with before, okay? Now, I'm going to skip over this next example. There's some word problem geometry stuff, x plus 6 times x plus 6. We're going to skip over that. There is a potential shortcut for this, but if it doesn't make sense to you, I want you to basically forget about it, okay? I want you to just do the FOIL method or double distributed property like you've always been doing. But if this helps you to shorten up or simplify that process, this is an option for us. When we have a binomial being squared, we can square the first piece, square the second piece. Okay, remember that's what I told you not to only do that. You can do those things as long as you remember the middle piece. Okay, and the middle piece is either positive or negative depending on what the sign in the parentheses is. And this middle piece is always 2 times the A times the B. Okay, so just as a quick example for you, if I have 2x plus 6 squared. Okay, that's going to be equal to my first piece squared, 2x squared, which is 4x squared, because 2 squared is 4 and x squared is x squared. And then my end is going to be plus my second part squared, so plus 6 squared, which is 36. And then this middle piece, because I have a plus sign here, I'll put a plus sign here. And 6 multiplied by 2, if I were to times these things together, like my a times b, I think I get 12x. And then this tells me to double it again, so it becomes 24x. Okay, and this is exactly what you would get if you did the double distributive property, combined the 2 pieces in the middle, etc. Okay, so this shortcut is available for you if you like it. If you don't like it or you're not going to remember it, then just do the FOIL method or double distributive property like you've always done. Okay. Now, the other special example we need to look at is these kinds of examples. Okay, so let's look at some of these guys. So in this case, we have 2 binomials being multiplied together. Okay, they are not the same thing, but they're really close to being the same thing. Okay, one is a plus sign and one is a minus sign, but other than that, they're exactly the same thing. Okay, so in this case, x plus 9 times x minus 9. Now I'm going to do this one like double distributive property and probably letter B as well, and then we'll sort of see what our shortcut can be, okay? So here I'm going to go ahead and multiply these together. X times x is going to give me x squared. X times a minus 9 is going to give me minus 9x. Positive 9 times x, if I go to the inside now, positive 9 times x is going to give me plus 9x. And then at the end, positive 9 times that negative 9 over there, positive 9 times negative 9 is actually going to give me a minus. Positive times negative is negative 81. Okay? So I have this polynomial, and then I'm going to combine the 2 pieces in the middle. So I want you to focus on these 2 pieces now. Okay? It says negative 9x plus 9x. So I have negative 9x's. I add positive 9x's, positive 9, negative 9. When I add them together, what do I get? I get 0, right? 0. Negative 9 plus 9 is 0. There are no x's in the middle of this polynomial now. These are totally gone. They cancel each other out, okay? What am I left with? I'm left with simply x squared minus 81. Okay, that would be my simplified version of x plus 9 times x minus 9. If I do the same thing here, and I go through my double distributive property, 6 times 6 is 36. And then I would have minus 6m squared. And then I would have, multiplying these 2 guys, I would have plus 6m squared. And then I would have, let's see, what happens when I do an m squared times another m squared? M squared times m squared, I should add the exponents together, so I get m to the 4th power, and a positive times a negative is going to give me a negative m to the 4th power. Okay, so now again, I have some pieces in the middle that are like terms, both m squareds, negative 6 plus 6, negative 6 plus 6, I add those together, I get 0, okay? 0, all gone. So all I'm left with then is 36 minus m to the 4th power. Okay, so now let's try to figure out what is our available shortcut here. Okay, maybe some of you can see it up here at the top of the screen, it's right here. But when we have the same thing in our binomials, the same terms, just with a different sign, plus or minus sign, the middle two pieces, you guys, are always going to cancel out. Always. They're always going to go away because one's going to be positive, one's going to be negative of the same thing. When we combine those, they're going to go away. So what we can do is, instead of doing double distributive property, we can simply take the first piece right here and square it. Okay, so if I look at this example, 3c minus 4 and 3c plus 4. If I take the 3c and I were to square that piece, 3c, and I were to square it, well, 3 squared is 9, and then c squared is just still c squared. And then I have a minus 4, and if I were to square the 4, I would get 16. Okay, so when I do this double distributive property, 3c minus 4 times 3c plus 4, if I were to do all of my arrows and I were to simplify things, I would end up here. I can sort of skip over that middle stuff because I know, because the terms are the same, just a different sign, the middle stuff is going to cancel out. Those middle two terms are going to cancel each other out, and I'm going to be left with this. Now again, this is a shortcut that is available to you, but it is not necessary to use. Okay, you can always just do the double distributive property or the FOIL method like normal, and the middle stuff will always cancel out. You'll be left with this quadratic binomial now as your answer. But if you can understand how this works, and we can sort of skip over that one step of writing out all 4 terms, you can just square the first piece, square the second piece, make sure there is a minus sign between them always, and that'll be the answer. Okay? If you have questions about either of these 2 shortcuts, please reach out to me somehow, email, phone call, or Zoom office hours. Otherwise, that is all I have for you for today, and we'll talk to you soon.